Hello friends, let us solve some example on moment of a force. So here we have example number 1. In that we required to find out moment of 100 Newton force about point A. So here one AB element is given and force is 100 Newton, that is applicable at point B with some inclination of 60 degree with vertical, and the distance between point A and B, that means the length of the element, that is 60 mm, and we require to find out a moment generated by 100 Newton force about point A. So we can find out this with two methodology. So here we solve it one by one. So let us start with methodology number 1. So here we start with first one, and that is by finding the perpendicular distance. Now here by finding the perpendicular distance, we just locate two lines. The first line, that is of we generally called a force line, and the second line that is exactly parallel to that we generally call a pivot point line, or we can say a reference line also. From that point A, we just extend one perpendicular on this force line, that is at 90 degree, and where it is actually connect, that point is known as a point C. So now this is a overall example. In that we require to solve the moment of 100 Newton force. Now we generally know that the moment is a force multiplied by perpendicular distance. So here our perpendicular distance is AC and the force is 100 Newton. So we require to find out what is the distance between A and C. So first we start with triangle BAC. So from the geometry of problem, we can take a triangle or a angle BAC, that equals to how much, that we require to find out. So here 60 degree is given. So by the extending this vertical line, we can also say that here this our angle, and you can say this outer angle is also a 60 degree angle by the law of the opposite angle, and this angle is our 30 degree angle because this is perfectly 90 degree, and here also 90 degree given at point C. So this remaining part or remaining angle, that should be 60 degree. So we can write down that angle BAC is equal to 60 degree here. So because of that we can write down AC divided by AB, that equals to cos 60, and if we solve that, we have that AC is equal to 30 mm, right? So between A to C the length is 30 mm. So by putting the value of AC in our equation of moment, that is moment is equal to, or we can say the moment at A is equal to force into perpendicular distance. So that is 100 Newton is the force and the perpendicular distance is AC. So now it is 30 mm. So if you multiply that, the answer would be 3000 Newton mm. And also we see that the direction of the force is about point A, that is anti-clockwise, so we can just also show a direction of that particular moment. So this is our first methodology to solve this example. Now look at to the another one. Now another one is by finding the component. So in components we just find out two component of 100 Newton force. So one component is in horizontal direction and another component that is in vertical direction. So horizontal direction component, if this is 60 degree with vertical, so we can write down this component is 100 sine 60 degree and this component is 100 cos 60 degree. So now we can resolve it with two number of forces. So again we just write down our equation of moment. So here moment at A is equal to, we just take a first force component that is 100 cos 60 and multiply with a perpendicular distance. So in this case the perpendicular distance is AB, so that is available 60 mm. So we can make the bracket for the unit, plus you can take another load or a force component that is 100 sine 60. So 100 sine 60 and the point where we actually want to take a moment, that is in the same line, so we cannot get the perpendicular distance in this. So we can also write down that 100 sine 60 multiply by 0. So this term would be completely a 0. So out of the calculation of the first term we can get the answer is equal to 3000 Newton mm, and also the direction of this component, that is anti-clockwise again. So this is we form as anti-clockwise direction. So this is the solution of example number 1 here. Now let us solve example number 2. Here also we require to find the moment of 100 Newton force about point A, but here element is somewhat different, that is in two component AE and EC. So we require to calculate moment about point A of given force 100 Newton at point C with some inclination of 3 to 4. So for that, first of all we take a first methodology, that is known as by finding the perpendicular distance. Now here we just extend a line of force of that 100 Newton force and another line that is known as a line of pivot point, or we can say a reference line, and we also draw a perpendicular of that line of force and line of pivot point, and we require to find out a different angle. So this angle is 90 degree. So if we sort out the angle at point C, so we can apply here a tan inverse 4 by 3, so that equals to 53.13 degree. Now considering that angle, we just find out the angle at point A, that is the target to solve the distance between two lines. So we just want to solve that distance AB, and for that we just solve this angle DAB first. Okay, now that angle, if we see, this is the angle at D, that is exactly same as the angle available here, that is 53.13, so that we call a theta. So here it is also a theta by the law of the opposition of the angle, or we can say vertically opposite angles. So by considering this DAB, we can write down is equal to alpha, is equal to 90 minus this given angle. Because this angle is if alpha, so this is already a 90, so remaining 90 that is shared by alpha and theta, so that would be come out 36.87 degree. Now similarly from triangle AEC, if we take and we find out another angle that we can call a beta angle, so here that angle, that is CAE, is equal to tan inverse, that is CE divided by AE, and put the value of that CE and AE. So again we write that is tan inverse CE is 100 and that AE is 250. So if you calculate, the answer would be 21.8 degree. Now here, considering angle CAB, we have overall angle is 21.8 degree plus 36.87 degree, so that equals to 58.67 degree. So that is the overall angle, that is alpha plus beta, you can say. So here we can say this is a beta angle. So alpha plus beta, that is the overall angle available at point A. Now considering triangle ABC, we have AB divided by AC, that equals to, if we apply a cos, so that is 58.67 degree, and by rule of triangle we can also use AC equal to under root of AE square plus CE square, and if we solve that, the answer would be 269.26 mm. Okay, this is the value of AC. So by putting that, what is the value of AB? So that equals to 269.26. use cos here, so cos 58.67 degree. That is the distance of AC line that is available, and to find out the angle, or we can say a length of AB, you can use that overall angle that is available with this line. So that is our beta is up to here. Okay, now we calculate moment. So distance is available, force is also available, so moment at point A, that equals to a force, that is 100 Newton, multiply by the distance, that is AB. Okay, we can calculate that AB. So AB value is turn out to be a 140 mm. Okay, so we put that 140 mm here. So the answer would be, if you multiply that and come out with Newton meter, so that is 14 Newton meter with the direction anti-clockwise, because this force is rotated about point A in anti-clockwise direction. So this is the first methodology to solve that example. Now if we see the second method, so second method is we can say by component. So here of the force 100 Newton, we have to take two component. One is a horizontal one and second one is a vertical one. So horizontal one, that is come out to be with cos, and so we can write down cos 53.13 degree here, and we can write down here sine again 53.13 degree here, that is multiply with this 100 Newton force. So we can also multiply with the 100 here also with it is 100. Also perpendicular distance available between this vertical force and the line of point, so that is 250 mm, and again with the horizontal, that is available 100 mm. So we can use that both the force and the perpendicular distance as well as this force and the perpendicular distance, so we can easily calculate the moment generated about point A due to that force. So we can take component one by one. So by taking moment of this component at point A, so our moment at point A, that equals to, so first we take that vertical component, so that is 100 sine 53.13 degree multiply by the perpendicular distance, so that is 250 mm, plus we can take second component, so that is 100 cos 53.13 degree multiply by distance 100 mm. Okay, if you solve that, you will get the same value, that is 14 Newton meter, and that is again in anti-clockwise direction. So this is the solution of example number 2. Now let us calculate this example number 3. So here the question is that find the moment of 100 Newton force about point D. So D is the pivot point and force is available at point A, that is of 100 Newton. So here we solve this example by finding the perpendicular distance. So again we start with this horizontal line that is available at point A, and that is parallel to BC line. So we have to first draw this line from the D, that is vertical line, and we just also extend the line of the force from that 100 Newton force. So that line is exactly connect at some location, and that we call as Q point. Now from D you can draw one perpendicular line from this 100 Newton force line, and that point we can call a P point. This is exactly 90 degree. Okay, so this is 25 degree, this is 90 degree. So here if we take this is 25, this is also 90, so remaining one is we can take as alpha. Again, due to that opposite angle, this is also alpha and this is also 90 degree, so this will be exactly a 25 degree. Okay, now this is 25 degree, again this is 90 in this triangle, so this will be remaining as 65 degree. So this is our angles available at different points. This point we can say this is point R. So first of all we require to find out the distance and that is the perpendicular distance between a pivot point and a force line. So that we can taking by the angle 65 degree. So if we write down here at 10 65 degree is equal to, one thing is given, that is 5 meter is available here, that is 3 plus 1 plus 1 divide by we have a RQ, that is the member, so that we can take here, and AR is available, that is 5 meter. So we can calculate very easily the value of RQ, so that is equal to 2.33 meter, that is the distance of RQ value. And now we apply a sine here, so sine with again 65 degree. So we can just write down here PD is the portion that we can take here. So here is our P and P and D. So that is one side, and below that DQ we take. So that is this one, D and Q. So we can also find out this value of PD here. So for that we can write down PD as it is, and what is the fragment of DQ, so that is of DR plus RQ, and that equals to, again we write down PD as it is, but dr we know that is 2 meter plus that RQ is 2.33 meter. So if you solve that, so you can get the value of PD is equal to sine 65 degree multiplied by total of 2 plus 2.33, so that is 4.33 here, and that equals to 3.92 meter. So now PD is the distance, that is perpendicular distance between the pivot point and the force line, so that is available. Force is also available, that is 100 Newton. So directly we can find out the moment. So here the moment at point D is equal to force, that is 100 Newton, multiplied by the distance, that is 3.92 meter, that equals to 392 Newton meter. So this is the solution of this example.